All right, folks, so we're going to be talking about random variables, and random variables is a new concept, and it's a new concept that's sort of going to put the idea of a sample space. We've talked about sample space in the first section of this course. It's going to put sort of that idea to the background, and you'll see why in just a second. So what are random variables? Random variables, very simply, are just a function from the sample space to the reals, or the real number line. So here's an example. So let's just say that this is our sample space. I'll put in an S so we know that's the sample space. And we have different outcomes inside of our sample space, okay? Like this. So then we've got our, let me try to do that a little bit better here. We've got our x-axis here. And we have different values here. So maybe we have a 2, 4, 6, 8. And all a random variable is, it's a mapping, or it's creating a connection or an association between an outcome and a numerical value here. Okay? So like that. Now, for learning purposes, it is always useful to make things more concrete. So this x here, and this is small x, by the way, could be, let's say, the number of patients a doctor sees in a day. Okay? So this is a discrete random variable. And really, at the beginning here, we're going to focus on exactly that. We're going to focus on the discrete case and then work up to the continuous case, which is a little bit more complex. And I want you to realize that this here is a small or little x. So when we look at the notation, of a random variable, we have the big X, which denotes a random variable, and then we have the little x. The little x is the numerical value, so this right here, that a random variable could take on. In our case, the random variable is the number of patients a doctor sees in a day. So a really good way of thinking about it is that the thing that we're measuring is the random variable. That's the number of patients a doctor sees in a day in this case, and that's our discrete random variable. The values of that thing that's being measured, so the actual number of patients, the numerical values, is going to be the little x. So then the usefulness or the utility of a random variable is that it's essentially a function that maps or associates or connects, whichever word you prefer, an outcome to an actual numerical value. So the final thing I want to mention is a little bit more notation. So the idea that the big X, okay, is just a function from S to the real line, or to the reals, and the numerical values it takes is the small x, which belongs to the reals as well. So hopefully you're a little bit comfortable now with the notation, because we did look at some of this notation in the linear algebra part of the course as well.